Quick intro. My name is Pavel Trinas. I go by Pav. I'm originally from Ukraine. That's where you kind of can hear Ukrainish accent in me. Came here roughly in end of '05, and since then just dove into IT. I started on a switch route, then switched to wireless, then looked briefly at servers, and then decided that servers not for me. Security was really my thing, so I decided to go into pen testing. I did a little bit of pen testing, absolutely loved it, and then decided, well, my side is really on the prevention side of the business, not so much of education of customers. So, with that, as of right now, I work for CDW as a pre-sales architect as of end of last year. And before that, I spent roughly 4.5 years helping local Minnesota customers. I'm in Minnesota, so I actually drove 3 hours here, helping them with their security needs all over the place. So with that, I would like to start my presentation by saying that I've done a lot of 802.1x installs. I've done a lot of NAC installs. Primarily, most of it was Cisco ISE. How many of you actually have NAC implemented at their work? So less than half. Less than half. Usually customers come to me and they say, you know what, I want certificates. I want to have a certificate on my PC to get on my network, and that will solve all of my issues. Right? No, that's not really the deal. And during this conversation that I hopefully will have with you, is I will show you what the differences are. I will educate you at a higher level as to what .1x is, what major flavors there are, what to do with them, and then, of course, why they are not your best solution if you're going for security. So with that, let's begin. Two major flavors that I see on the networks, they are TLS and PEEP. So TLS is really a certificate-based authentication where the supplicant as well as peer, both of them have to trust each other. So your laptop or PC would have a PKI issued certificate, as well as behind the switch, some sort of a NAC device would be Microsoft NPS, Cisco ISE, Aruba ClearPass, whatever, right? They have to trust each other and build that mutual trust to exchange those credentials. And then at the switch level or the port level, they will be allowed to get on the network. Then they can get ACL applied or limited access and so on. With PEEP authentication, there is only one site certificate where ISE ClearPass or something else would have, and client has to trust that. In that setup, we are using Microsoft credentials to pass over the encrypted channel to get authenticated and make sure that, yes, I am who I am. Now I'm allowed to get on the network. In those credentials, usually we see either a machine credentials once the machine is on the Active Directory, or user credentials, or a combination of two. So, any questions? Good. Let's look at what happens at the port level when we are doing the certificate. So once the connection happens and the certificate at machine level exchange happens, that's where the user is yet to be logged in to the machine, right in the middle, and we can have a very specific ACL applied, and that's kind of best practice where the machine can talk to Active Directory, DHCP, DNS, maybe some sort of update server to get everything. But we do not allow that machine completely on the network. Why would we? Why would that machine need access to the internet, right? And then when user shows up and when user logs into the machine, a next series of events happens where that user within Windows has to authenticate itself, ideally. Once the user authenticates, then we start to see, okay, Are we on HR network? Are we in legal? Are we in IT? And we give certain privilege level to that very specific user based on the certificate that was assigned to the user, right? Those credentials. Once we limit that ACL at the port level, what happens after? Well, not much. At that point, we just start to see certain counters increase until the next reauthentication. By that point, from the switch perspective, that Mac, that machine, that user is completely trusted with exception of what ACL is limiting to that machine. So keep that thought. Super quick, the difference with PEEP MS CHAP, we're just not doing certificates for the user, we're not doing for the machine, we're just using machine credentials and user credentials. I would highly suggest not going user credentials in here just because they're so easy to pass on, right? But machine credentials is very nice, very secure. There are no known to me ways how you can extract it and reuse. You can extract, but not reuse. There is no pass the hash, there is no tokens that you can steal from the machine credentials. That's why the machine piece is fairly secure. It's even, in my opinion, it's way more secure even than a certificate because you can actually extract the private side of the certificate with the usage of proper tools. So once we are on the network, what else can prevent us from spreading deeper? And I'm really thinking from the perspective of pen tester or bad guys that once they are there with their own laptop with a Linux or something else, they have access to what the machine had access to. If it's IT, you have access to the full network. The biggest question of tonight, what can break that? A 5-port switch. A dumb 5-port switch. Even a hub. Let's go lower. Why? The dumb portion is that it has to be unmanaged, 1. It has to not have its own MAC address, 2. The reason is that when we put this little thing in the middle of good machine and this smart switch, so right in the middle from a high level point overview, we have the supplicant that can authenticate completely to the switch. Certificate, non-certificate, I don't care. Once the hub, so let me start with the hub. Once the hub is in place, what does hub do? It replicates everything to every other port. Where do we need it? To sniff all the traffic, all the clear text, whatever our supplicant is sending. As long as we are in promiscuous mode on our NIC, the smart switch will never see our MAC address. It will never start to authenticate us as a new session. It will never know that we are behind a hub. And we're just there sniffing it all. Now, how can we put ourselves instead of supplicant? What I've done previously is instead of a hub, I would put a switch in place. I do not get the visibility, full visibility, but I plug in the supplicant, I know that it's fully there. I know the MAC address. I can spoof the MAC address to myself. I unplug the supplicant. Now what happens when I unplug the supplicant? The switch port, the smart switch port, it never goes down. The smart switch never knows that something got unplugged. The smart piece got unplugged. It does not restart authentication. It does not force it. So I'm walking in right at the point where ACL, previous ACL was applied. At that point, I'm spoofing my MAC address on my bad machine. I'm plugging in into 5-port switch, and I have previous access. Would it be IT? Would it be whoever? I don't care. No, I'm spoofing the MAC, and I have access to the network. Yeah. I have the network. I can go after the servers. I can penetrate deeper. if I can get to certain credentials, I can actually give myself more access at that point once I'm there. Now, why does this method better than other methods that usually guys and gals are going after? If you look at .1x configuration on the port, and I'm just going by your typical either Cisco best practice or some other vendors, is that there are two parts to authentication to a wired port. You have 802.1x, and then if it fails, and it has to fail for certain number of devices, your access points, your printers, your VoIP devices, the dumb devices that cannot do 802.1x, they're not smart enough, it has to fall back to MAC address bypass. At the MAC address bypass, a lot of companies, they're like, well, anyone can spoof me. So what they do, they put the ACL so strict that when you get access to it, you cannot go anywhere. You can go to a phone server, printer server, or somewhere else, and you're enclosed. That's why this method, going after actual workstations, is much better when you're looking at penetrating deeper into the network. Any ideas on how to prevent this from happening? Yes. Time to time, back to timers, absolutely. But how does that work? So if you put your timers down to 5 minutes, it's a huge load on the network. If you put it up to 10 minutes, you're at 10 minutes. Well, let me go feed my meter every 10 minutes by unplugging the cable, plugging back to authenticate. That's it. Any other ideas? Good, let me give you one. MAC-SAC. Smart guys and gals developed this in 2010, only 9 years ago. What the MAC-SAC does is a MAC layer VPN type solution where endpoint can establish a secure, nice tunnel to the smart switch. At that point, that hub in the middle, that switch in the middle, they're useless because all they see on the wire is, I want to say gibberish, but I'll say Ukrainish. All they see on that wire, that's it, nothing else. So at high level, it would look something like this. This is before 2010. Like I said, we put a hub, we can sniff it, we can look at everything. One step back, kind of a left image, when properly deployed NAC solution, at the port level of the switch, you only start to communicate EPOL, extensive protocol for authentication over LAN, where no DCP, no DNS. Once you authenticate, then you're permitted to do more on the network. Once that good supplicant authenticates, then we kind of open up the full network to it. That's where our hubs and switches come into. Cool things you can do with it. If you have an access point, put a MAC address on it, now you're hacking from a parking lot. Well, bad news, right? You're no longer at the port. You can put it under the desk. You can do pretty cool stuff. You can have some sort of a router / firewall where on one interface you put a MAC address, then you start to net more devices behind. Now you can put a nice little army and go after the client. Really useful if you have larger customers with say you're walking in with 5, 10 PCs going after 10,000 plus endpoints, and you want to complete the job in 2 weeks. So after 2010, with proper implementation of MAC-SAC, and I will go a little bit into what it really entails, there is no spoofing. You see the Ukrainish? Good stuff, right? No spoofing. You cannot read it. The Wireshark will not yield you anything when you get all the port information into yourself. So at a lower level, MaxSec really is a nice addition to 802.1x. So once 802.1x is done, once we're done with it, MaxSec can do its own key exchange and encryption and building out that nice tunnel, and it will continue. Kind of like you walk in the door, you show your credentials, and then the guard walks behind you everywhere without letting you go. Limitations, actually a ton. So 9 years, very new. There is no high availability to it. One port, one MAC address, you cannot do a lot. You cannot bundle the ports for servers if you're using some sort of a port channel for it. If you're looking at very specific vendors, so I can pick on, for example, Cisco. You have certain switches, 48 ports, but only the first 16 will support MaxSec. You look at Juniper, only very specific models will support it, but not others. So looking at the vendors, what vendors do when in preparation for MaxSec delivery, it will help a lot. Private VLANs, it will not support that. You got to get rid of that. Only very specific endpoints support natively, and I will go into that a little bit later. And then also Microsoft, it does not support MaxSec at all. Good news, right? For Microsoft. So NPS, nice platform from Microsoft. They do not support it, period. Microsoft, even Windows 10 will not support it as of right now. I'm not sure why, but there are other ways how we can fix it. So one thing to mention is that a good fix, in my opinion, good, right, is AnyConnect. AnyConnect from Cisco has the capability of replacing the network access module within Windows or within Mac or somewhere else, where it completely replaces that module and it can behave on behalf of the OS, and it can provide the MaxSec. So if we look at the AnyConnect, here I'm showing the configuration portion of the profile for AnyConnect. So one profile, you configure it, you can configure for 802.1x. You can add the MaxSec, you can put wireless security, everything in here on top of VPN. Usually what people know AnyConnect for is VPN, right? Once you put that, then you distribute everywhere, and then it works everywhere. Configuration is super simple. 2 drop downs, you figure out what do you want, you're done. Again, as long as your back end of the house actually is set up for it, right? If it's not centralized, how would you do it? If you give your end users enough authority to move around the workstations, hopefully without admin privileges, you can give them the authority to do it manually at the AnyConnect level. Again, under networks, just a few drop downs and be done with it. From AnyConnect. So AnyConnect really fixes the problem of Windows, any Windows for that matter, from XP down to Windows 10. It fixes the Mac because Macs do not support it natively, even though it's Linux, right? What's wrong with them? But one OS that truly supports it natively would be your Red Hat. Red Hat with WPA supplicant, it will natively support it. It's roughly 15 to 20 lines of code. Once you put it in, you're done. I already mentioned the reauthentication timers. They're good. You can monkey around with them. They can give you, on average, 5 minutes. But that is not sustainable in larger organizations. usually when I go out and I deploy Cisco ISE, for example, timers would be around 24 hours for the reauthentication, at a minimum of 8 hours if we're talking 40 to 60,000 endpoints. Yeah. Any questions? Okay. There is no latency. So the max sag is at the wire level because it's layer 2. Right now, I've seen where you can go up to 400 gig on a wire with max sag. No issues. It doesn't. So our poisoning is kind of on the side, right? You put it into ARP table, you're done. This one is really to secure communication between endpoint and the switch. In this case, there are other ways though. So I had customers where they would come in to me and they say, I have 2 locations. I do not trust my ISP. They are providing a layer 2 clean, but we all know that it's a VLAN tagging all the way through the internet, and it's like, who would trust it? He's like, I want something else. I'm like, okay, let's do uplink max sec. So between switch and switch that you plug in, we can secure that. At that point, again, encryption is your layer 2 tunnel like IPsec instead of IPsec, just to get rid of all the latency that IPsec brings in and the CPU heavy intention. Yeah. To which stacks? I'm not sure. What a downgrade attack is. Right. So if I go back a few, here we go. You can actually set up encryption, which encryption you support, and at which level you will negotiate the encryption. So just like IPsec, right? You can set up IPsec and say that I'm supporting only AES 256 and nothing else. So there is no downgrade. You can limit at that level. Any other questions? Good stuff. Thank you.